Welcome to two-dimensional arrays. In this lecture, we'll be understanding what a two-dimensional array is. We'll be looking at how we declare two-dimensional arrays. We'll be understanding how we can find the length of a two-dimensional array. And then we'll be applying for loops with two-dimensional arrays. And then we'll finish off by doing some basic definitions of, we're basically declaring and defining two-dimensional arrays in a live programming environment, and then printing out the different elements in these arrays. So let's start off by understanding what a two-dimensional array is. So a two-dimensional array is something that we use to model board games or anything like that. Usually something like a matrix. So originally we've used arrays before, and in arrays we might have something like 3, 5, 9, 0, 8. Or we might have something like 4, 1, 7, 2, 6. These are all different elements. But let's say that we want to combine these two different arrays into one array, and we don't want to combine them so that they're all in one line. We want to combine them so they're in two different lines. And that's something that you're not capable of doing with a regular array, because a regular array only spans across one line or one row. But in the case of two-dimensional arrays, we can have more than one row. And this example I've shown you is a 2x5 matrix when the two different arrays are combined. And let's say we want to access the 7. So what we do is we do array name, which would be replaced by whatever the name of the array is, brackets 1, brackets 2. So what this is doing is, this is saying we're going to go to the first row and the second column. So remember, counting in computer science starts with 0. So we'll skip the 0th row starting with 3, and we'll go to the first row, which starts with 4. Then we'll go for the second column. So we'll skip the first column, the 0th column, which starts with 4. We'll skip the first column, which has 1, and we'll reach the second column, which is 7. And that's why this statement evaluates to be equal to 7. And now let's look at declaring these type of arrays. So in order to declare this array, two-dimensional array, it's not really much different from declaring a regular array. And keep in mind that a regular array could be referred to as a one-dimensional array. So what we're doing here is we're saying int and then two pairs of brackets, array name equals new int, and then bracket 3, bracket 5. And that's basically saying that we have 3 rows with 5 columns, and the only difference really is that we're adding another pair of brackets on both sides of the equal sign. One usually would say something like int brackets, only one pair of brackets, array equals new int 3. But in this case, we're adding a pair of brackets to the left of the equal sign and to the right. And that's basically indicating that we're going to have rows and columns, not just columns. So it's basically saying we can have more than one line or more than one row. So the overall syntax for this would be type brackets. So whatever type is of the elements. Array name equals new type. Then number of rows and number of columns. So you would replace hashtag R and hashtag C with the number of columns you'd like and the number of rows you'd like. So let's look at an example. We've looked at declaring and creating arrays that way, and then we've also looked at them using the array initializer. And we've discovered that the array initializer is a lot more convenient way to do this. And don't worry, there's also a way to use the array initializer with two-dimensional arrays. So we could go double brackets d equals, now within the braces we have a first pair, which is 2.3, 3.4, and then we have 4.5, 6.7. Now keep in mind that within the second pair of braces, so we have one overlying braces, and then within those we have two pairs of braces. So the braces surrounding 2.3 and 3.4, we can put multiple more elements into this. We could add in any other element into this within those two braces, and that would thereby increase the length of this of the row. So let's look at how this comes out to be. The way the computer will see it is outlined below this initializer, which is 2.3 and 3.4 are on their own row, and 4.5 and 6.7 are on their own row. And keep in mind that we can add a few more rows by replicating what we've done. And we can also, add some more elements by just going 2.3, comma 3.4, comma 6.9, anything. We can keep adding on to rows and making them bigger. So that's another way. Now let's take a look at how we can determine the length of a array. So basically we want to find out like how many rows it has, how many columns it has, anything like that. So let's go away from two-dimensional arrays and think about one-dimensional arrays first. With one-dimensional arrays, if you go array name dot length, so array name would be replaced with whatever the name of the array is. If you do array name dot length, it returns you the number of elements in this specific array. Now, the thing with the array.length, when you use that with two-dimensional arrays, it doesn't return the number of elements in this specific two-dimensional arrays. So let's say that we have a two-dimensional integer array named x, and we say x.length. X.length will return the number of rows, and then if we go k x and then k in brackets dot length, we'll get the number of columns. Now this is assuming that it's a rectangular array. If it's not a rectangular array, we can have some problems, so we'll be using rectangular arrays. And basically what this is doing is that k would be replaced by any column, any number that would be fit inside of this array. So we could go x in brackets 0 dot length, and that would tell us how many columns there are. So x dot length is for rows, and then x brackets k dot length is for columns. Now let's look at for loops with two-dimensional arrays. So let's start off by declaring an integer variable sum, which is equal to 0. And now let's say that we want sum to be equal to the value of every single element in this two-dimensional array added together. So we'll go for int r equals 0, r is less than x dot length, r plus plus. So remember that x dot length represents the number of rows. So basically what we're saying is, starting with the 0th row, we'll keep going through every single row, and within every single row we're gonna go from int c equals 0, so the 0th column, to the last column. So for int c equals 0, c is less than x r dot length, c plus plus. So basically what we're saying here is that within every row, as determined by the first for statement, within every single row we're going to be going from the first column, is the 0th column, to the last column. And what we're going to do there is we're going to say sum plus equals r and c. So r would be whatever the value of r would be at that point, and c would be the value of this. So basically, let's say we start off with r equals 0, then we go to the second for loop and c is equal to 0. So sum plus equals x0, 0, and then c plus plus, so c will be equal to 1. So that now will be sum plus equals x0, 1. So this is what we're called using nested for loops, and the for each statement can be used as well, because we're simply accessing the elements. We're not modifying or replacing them, and the for each statement would probably be a better fit here. So now let's move to a live programming environment where we'll be declaring a two-dimensional array, and then after that we're just going to be accessing its different elements. So here we are at Dr. Java, and we have 2D array test.java program ready. The class and the main method have been declared. And now let's start off by declaring our first two-dimensional array. So let's go int, two brackets because it's a two-dimensional array, x is the name of the array, equals, and let's say new, let's use an initializer. So we start off with brackets, and then we go brackets again, and let's say we go 3, comma 4, comma 5, and then that's our first row. So our first row will be 3, 4, 5. So our first row looks like 3, 4, and 5. Then let's get our second row, which will be 4, let's see, 9, 1. And now let's go to our third and final row, which will be, let's say, 7, 8, 2. And there we go. This is our this is our initializer. So what this will look like is 3, 4, 5 in the first row. In the second row, we'll have 4, 9, 1. And in the third row, we'll have 7, and 8, and a 2. So this is exactly how our entire array is going to look. It's going to be a 3 by 3 matrix, and it's going to have 3 rows and 3 columns. And that's what we're going to be working with for this example. And now let's say that we want to print out, let's say we want to print out the 9 right here. We want to print out this 9. So what we're going to do is we're going to do system.out.println, and then we go x, which is the array name, comma. Now 9 is in the second row. So in programming terms, that's a 1. So it's actually in the first row. So 9 is in the first row, and 9 is in the first column. So then what we do is, this is what we do, and x11 should return 9. So let's compile, and let's see if 9 is printed out. So 9 is printed out. Now if I were to change this second one to 2, now what this does is, this first goes to the first row, so it goes to the row that starts with 1, and then it goes to the second element, so 0th, first, and then second, so it would print out 1. So let's compile, and let's run. So as you can see, 1 is printed out. And let's look at our last example for this program, and that'll be, let's print out the 2. So what we do is we change since 2 is in the second row, we make this 2, and it's in the second column. So now we can compile and we can run. As you can see, 2 is printed out, and the reason 2 is printed out is because the computer goes 0, 1, 2, so 2, and then 0, 1, 2, and it reaches 2. So that's how the computer works. And here we've taken a look at two-dimensional arrays in this lecture, and two-dimensional arrays are immensely useful when you want to model board games or anything that has multiple rows and columns. One of the disadvantages of a regular array is that there can only be one row, and two-dimensional arrays are there to solve that. So we just looked at basically declaring a two-dimensional array with initializers and then accessing its different methods.